Well, okay, let's start having a look at some of these calculations using the formula that we introduced in the last video. Okay, so this time around we're going to use the idea of the mole to calculate a number of particles. Okay, so hopefully you remember that the number of particles is equal to the amount of substance in mole multiplied by Avogadro's constant. Okay, and essentially that means that the number of ions, molecules or otherwise in mole multiplied by 6.02 times 10 to the 23 using this formula here. So n number of particles, and always specify, okay, we always need to specify what our particle is, multiplied by the number of mole of a substance in MOL, whoops, and then Avogadro's constant, which is 6.02 times 10 to the 23. Okay, so this is the formula we're going to use, so let's have a look at a couple of example questions. Okay, so we've been asked to calculate the number of atoms in 4 mole of sodium atoms. Okay, so the things that we need to look at here is that we're looking for the number of atoms, so I'm looking for big N is going to relate to atoms. I've been given a number of mole, so I've been given little n, okay, and then sodium atoms is the thing that I'm looking for. Now, because I have a look at my formula, sodium comes in, so we've just got sodium atoms, single atoms, okay. We're wanting to count atoms, so there's nothing special that I need to do with this. So we're looking for big N. We know that Na is 6.02 times 10 to the 23. Remember, this is in our data book. Okay, and then we also know that little n is equal to 4 mole, because we got that from the question. So if we substitute this into our formula, so little n is equal to big N on Na, and we rearrange, we will get big N is equal to little n times Na. So we just substitute those in, and we get 4 mole is my little n, and then this is Na mult, and that is of course going to give me 4 times 6.02, and this is the kind of question that you can expect to see in paper 1, because they're ones that you can do without a calculator. So we'd get 24.08 times 10 to the 23, or we can write that as 2.408 times 10 to the 24, and then we would specify here atoms of sodium. Okay, so remembering that in paper 1 you won't have a calculator, so they will usually keep your calculations to whole numbers, so this would be something that you might have to do for a multiple choice question or something like that. Okay, so let's have a look at our next example. And we're asked to calculate the number of molecules in 2.5 mole of CO2. Okay, again, it's asking me to calculate molecules, and I've been told I have a number of mole of molecules. So now all I need to do is I'm looking for big N of CO2, and you'll notice here that we're using these brackets to specify what it is that we're counting, the number of CO2 molecules. Okay, Avogadro's constant. Our number of mole was given in the question as 2.5 mole of CO2 molecules. So now we can substitute into our formula. Get 2.5 times 6.02, and hopefully if you guys plug this into your calculator or do it in your head, you're going to get 15.05 times 10 to the 23 molecules, or as we said before, 1.505 times 10 to the 24 molecules of CO2. Okay, so again, just another simple substitution and into our formula. Okay, so this time, number 3, we've been asked to find oxygen atoms, so just O, always check to see if it's O or O2. Okay, remembering when it's formed a compound, it's not oxygen molecules anymore, it's gone into forming a new compound. So we need to find the number of oxygen atoms in 2.5 mole of CO2 molecules. Okay, this time we've got a difference. Okay, we can see we want to count atoms and we've been given molecules. So we've been given the number of mole of this whole unit. Okay, and what we want to do is find out one part of that unit. So what we can see is if we write this out as a ratio, O is to CO2. For every one CO2 that I've got, I have 2 oxygen atoms. Okay, so I can set it up in a grid like this. Okay, and I've been told that I have 2.5 mole of CO2. So if I put those under CO2 there, okay, and then what I want to know is X, because I can't use this one. Okay, I can't use this formula until I know the number of mole of oxygen atoms that I'm dealing with. Okay, and at this stage, all I have is a number of mole of CO2. So I want to find the ratio of oxygen to CO2. Okay, and if you can do that in your head, that's great, but it's a 2:1 ratio, which means that I will get 2 oxygen for every 1 CO2, which means I will have 5 mole of oxygen. Okay, here's the thing. Okay, so we've got our 5 mole of oxygen. Okay, sometimes the numbers get tricky. So if you set it up in this grid-like fashion here, we can then go cross multiply. So I get x, 1x is equal to, 2 times 2.5. And that's going to give me 5. Okay, it doesn't matter, sorry if I keep swapping that slide there, it doesn't matter which way you do it. If you can do it by inspection, by just seeing the ratio, or if you set out this grid, all you need to be able to do is mathematically see, determine how many mole of oxygen we would be getting from each CO2 molecule. So now if we're looking for the number of oxygen atoms, okay, I'm going to substitute into my formula and have N times Na. Because I'm looking for oxygen atoms, I need the number of mole that corresponds to oxygen, which is the one that we found there. So that's going to be 5.0, and then this is going to be times 6.02 times 10 to the 23. Okay, so if we do it this way, we're going to see that we will have about, so 6.02 times 5 is going to give me 30.1 times 10 to the 23, or putting it into correct scientific notation, times 10 to the 24 oxygen atoms. So this one was a little bit trickier, where we had to look at the number of parts of the molecule that we were talking about. Okay, so what you can think about is, if you think about one CO2 molecule is made up of a carbon and 2 oxygens. So if we have this as a whole, we actually want to count, we're counting out how many parts. Okay, so they are the different types of calculation that we can be expected to use using this formula. So have a go at some of the ones in your textbook, and we will practice these in class as well. But you've got these to come back to if you're unsure. So remember, this is always counting the number of particles given the number of mole. Okay, and we'll look at some new ones in the other videos.